Today we are looking at an aspect of STEM, which is science. Well, in different parts of the world region, you can call it general science. It can be primary science. It can be elementary science. Like in my country, for the junior secondary school cadre, they call it basic science. We're looking at a topic under this, which is called atoms, cells, the building block of matter. Atoms and cells, the building block of matter. And this class is designed for students in primary school from primary 3, 4, 5, 6, and of course for junior secondary school, JS1 to 3. And it could also be very useful for students that are beginning subjects like chemistry in the senior class, the SS1, the year 1 senior high school students can find this also very fundamental and a foundation in which to begin to build their scientific knowledge at a higher level. Now we're looking at, there are three terms that make up this topic: atom, cell, and matter. We shall be looking at them one by one. Let me start with atom. Atom is associated with non-living things. Cell is associated with living things. And of course, you know that living things can either be plant or animals. Now, let's look at atom. By definition, look here, an atom is the smallest indivisible, that means which cannot be divided, particle of an element, if you like, or of a substance, element, or you can put of a substance that can participate, or that can involve in chemical reaction. For example, all the cooking process that take place in your kitchen are reaction. Okay, so an atom, every of those ingredients, the maggi, the salt, the water, can be rendered to atom, smallest part of those ingredients. They participate in reaction. So I take that again. An atom is the smallest indivisible particle of an element that can participate in chemical reaction. Take note of the word smallest indivisible. If you have a substance like this, let's say this represents an element. If I divide this into 2, half of it is gone, right? I divide this into 2, half of it is gone again. Is that not so? I divide this into 2, half of this is gone. You keep on dividing until you get a state where what you have cannot be divided again. Okay? It becomes what? An atom, the smallest indivisible. Now, take note of that definition. So I want to clean this definition so that we can look at other things that relate to that atom that we have just discussed now. Now, look at this. Look at this diagram here. This is diagram 1 here. 1, 2, and 3. This number 1 is an atom of a particular substance or element, okay, called sodium. If you look at it, if you study this through an instrument called microscope, a microscope is an instrument that can enlarge things that you cannot see with your naked eyes. It will be enlarged under a powerful microscope. And a good example of a powerful microscope is called electron microscope. Now, if you study an atom, that thing that we have discussed as being the smallest, this is the structure it will give you. It has 2 major parts. An atom has 2 major parts. It has number 1, the nucleus. Which is at the center. That one is centrally located. Can you see? That is the nucleus. Then we have the second part of an atom are the shells or orbits. the shells or the orbits. Those are the ones, look at it, that look cyclic, like it's like circles. Like for sodium atom, we have 3 of them. 1, 2, and what? 3. We call them orbits or shell. So an atom has 2 major parts, the nucleus and the shell. Another name for the shell is what? Orbit. For sodium, this is sodium, Na. That's the symbol for sodium, Na. It has 3 orbits. So different substances, different elements have different number of orbits, okay? But the nucleus is at the center. So don't forget, part of an atom are the nucleus and the what? The shell. Now, again, an atom has some particles. What are the particles that we can find in an atom? Particles. Particles. There are 3 major particles. We have number 1, protons. Protons. We have number 2, neutrons. The neutrons. Then we have the last one, electrons. Now, these 2 particles, proton, which is P, neutron, which is N, electron, which is E. The first 2, protons and neutrons are at the center of an atom. That means they are inside the nucleus. Take note of that. The protons and the neutrons are where? Inside the nucleus of an atom. The electrons, those ones are arranged along the orbits. These dots, this one that I represent like this, are the electrons. Like if you count the number of electrons here, you will count, let's start from the center orbit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It means that sodium, as an atom of an element, has 11 electrons. So each of these stand for electron, okay? Then the protons are at the nucleus, are inside the nucleus. Now, these protons, these particles carry charges. Protons is positively charged. Take note of that. Neutron, from the word neutral, it doesn't have any charge. Nil. It doesn't have any charge, okay? Then the electrons, those ones are negatively charged. Protons are positively charged. Electrons are negatively charged. Okay? Now, these protons resemble atom of hydrogen. Hydrogen 1. This proton resemble hydrogen 1. Okay? This electron resemble a particle called beta particle. Beta particle. Electron. And the symbol for electron is this. E minus 1, 0. Like this. E minus 1, 0. This minus negative shows that it is negatively charged. This 0 up here shows that it has no mass. The mass, the weight is almost 0. Okay? Of an electron. So don't forget that an electron is almost weightless. But if you look at the proton resemble hydrogen atom. Is that also? If you look up here, what is that? It signifies that the mass is 1 gram. Up here is the mass. This one is the atomic number. Okay? Okay. Now, so protons, an atom has 3 particles. Now, if you look at these 2 particles that make up this nucleus, that are found in the nucleus, one is positively charged, the other one does not have what? Any charge, neutral. So it means that plus neutral will give you plus, because neutral means no effect. Okay, it's colorless, something that does not have any does not influence anything. It does not affect anything. So if you have a positive charge with a neutral charge, it will be what? Positive charge. So it means that the nucleus the nucleus, which is made up of protons and what? Neutrons, is also positively what? Charged. Is that clear? Okay. So now let's look at some other aspect of particles. Who are the scientists? Scientists that work on atoms, that study, that discover atoms, or that do one research work or the other on atom, or that observe what an atom is. Scientists. There are some scientists that you need to know. One of them is John Dalton. We have Thomson. We have Henry Rutherford. Then we have Niels Bohr. Take note of that. These are scientists that work on atom. We have John Dalton, John Thomson, Henry Rutherford, and Niels Bohr. Please take note of that. Now, let's see an atom as the building block of matter. Now, let us see how an atom is the building block of matter. Don't forget that matter can be divided into non-living matter and living matter. And I told you that an atom is related to non-living atom. How does it build up from atom to compound to substance? When you say compound, it means the substance you use at home, the substance in your environment. Look at the build up. From the smallest, it build up to what? Elements. It build up to what? Molecules. We have ions. Then it also build up to what? Radicals. Then you now have the substance. What the commonest substance we use at home or in our environment is what? Water. Look at it. H2O. Sulfuric acid. We use this one. You know, water is a universal solvent. Water is also life. We use water for so many things. Is that not so? Okay. H2SO4. We call this one sulfuric acid. It is used in producing your detergent, the soap. One of the major ingredients for producing is sulfuric acid, H2SO4. We have calcium carbonate, CaCO3, calcium carbonate. It is called limestones. It could be found in our environment. It is used to produce cement. We have sodium chloride, NaCl. That is the common salt in your kitchen that you use to cook. Sodium chloride. Sodium, it is made up of sodium and chlorine atom. Okay? So from atom, we have it built up to all kinds of matter which result into compound or some substances. So this is the structure of an atom, and specifically the structure of sodium atom. Alright, now let's go to cell. What is a cell? A cell is the smallest unit and basic building block of life. Hello? A cell is the smallest unit and basic building block of life. A cell is a component of the living matter. It's a living matter, like plants and animals. It builds up into an organism. Cell build up to form what? Organism, like dog, animals, plants, lion, human being. We call them organisms. See how it build up. It build up from cell to form what? Tissues. It means that tissues are a bunch of cells, many cells coming together to form what? Tissues. Then tissues are then from tissues we have what? Organs. What are organs? Organs are many tissues coming to form what? Organs. A good example of organ in human body system as the stomach. Stomach is an organ. The liver, our liver is an organ. Then the heart. Okay, so several tissues form organs. Then different organs result into what we call what? Systems. What are the systems in your body? Digestive system, that this with how you eat, how the food eat is broken down. The skeletal system, which is the bone, and how you are able to have a firm, rigid structure. The reproductive system, how you give birth to young one. The respiratory system, the excretory system, the nervous system. Then several systems now result into organism, which can be human being, dog, and so on and so forth, male or female. You can see it there, an organism. Okay. Now, a single cell, which is the smallest unit and basic building block of life, okay, can perform the following function. A single cell, as small as it is, it can store food, it can use energy. Don't forget that the stored food is energy. We call it chemical energy. The food that you eat, once it is digested, results into chemical energy. So a cell, which is the smallest unit, can store the food, can use energy. It can protect itself. A cell can protect itself. Then it can reproduce. So they are the smallest unit of life, or the basic building block of what? Life. Now, look at this diagram. This number 2 and number 3. The first is animal cell. The second is what? Plant cell. When you study a single cell, your eyes cannot see it, your naked eye. So we use an instrument called microscope that I told you about the other time. Microscope. A good example of that is electron microscope. If you study a plant cell through electron microscope, you will get a structure like this. The biggest part of that structure, inside that structure, is nucleus. So there's also a nucleus here. Just like an atom for non-living things have nucleus, okay? Animal cell that has life has nucleus. For the plant cell, the largest part, look at it, the largest part component that you can see inside plant cell is called vacuole. Now, the other parts, all these things that you are seeing, all these structures, all these components you are seeing, including the nucleus for animal cell, the vacuole, and all these other ones, we call them organelles. Let me clean this. We call them organelles. They are the parts of either animal cell or plant cell. We are not going into details of that for today. Now, the first scientist in 1660 to single out a cell, to discover a cell, is Robert Hooke. Robert Hooke is the first scientist to single out. The first cell to be observed, to be discovered, was discovered by Robert Hooke in the year 1660. That's a very long, over 1,000 years ago. Did you understand that? Okay, so now, it means that there is a difference between animal cell and what? Plant cell, by what you are seeing. And if you look at the organelles, there are some that resemble, okay? Both animal cell and plant cell. So they have differences and they have similarities. That is subject for another day. Now, that take care of what we need to study under cell. Now let's start look at what both cell and atom result into. Atom and cell build up to what is called matter. And that will be the last thing we are going to discuss, okay? So all these things that you are seeing here, whether it is an atom or plant cell or animal cell, we call them matter. Whether it is water, H2SO4, calcium carbonate, or sodium carbonate, we call them what? Matter. Whether it is an organism, male or female, they are all matter. Now, a scientist called de Broglie de Broglie, came up with a formula of whatever thing you can find in the universe, in the world. He says that the universe is made up of matter and light. Of course, the opposite of light is darkness. Is that not so? It means that in the world, everything that you see are matter. What God creates are matter. What God enables or empowers man to create, like the toothpaste, the cup, the aeroplane, the cars, are also called what? Matter. It means that everything that you can see or feel, like the gases, carbon dioxide, carbon monoxide, oxygen, are all what? Matter. So that means the whole world, the universe, is simply made up of what? Matter. Now, what is matter then? Let's define matter. Matter is anything that has mass or weight and can occupy space. Matter is anything that has mass or weight and can occupy space. Now, how do we now classify matter? Matter can be classified into two: non-living matter and what? Living matter. Now, a matter has three states. A matter has three major states or phases. A matter that you see in your environment, that the whole universe is made up of, can either be, solid matter, which is technically called solute. It can be liquid matter, which is solvent. Then it can be gaseous, which is like vapor. So matter exists. The matter in the environment, a good example of solid matter, the stone, the cup, okay, the sand, they are solid. Liquid matter, the water, the kerosene, the petrol, solvent. Then gases, oxygen gas, carbon dioxide gas, carbon monoxide, sulfur oxide. There are all kinds of gases. Is that clear? Make up the matter system of our world. Did you understand that? So matter is anything that has mass or weight, and matter can be classified, like I told you the other time, into two: living matter, which we study under cell, and non-living matter, which relate to what we study under atom. Living matter relate to what we study under animal cell and plant cell. Non-living matter relate to what we say under atom. So, with this, we have come to the end of the most fundamental thing you need to know in science: atoms and cells, the building block of matter. So, don't forget about this. We in our next video production, we will talk more about what all these things stand for and looking at their definitions, okay, as substances that are within our environment. I believe this foundational expository in science will give you an edge to be able to discover more things you need to know in science. Till my next video production, we have a great time. Bye.
Butter my bread, sugar my tea, give me a cocoa. Ain't nobody touching you when they try to touching you. Everybody crushing you, but I'm wanting to marry you. I never carry another, you know say I be complete, man, yeah. Now your matter, you pay for my money inside, yeah. Mommy, water, baby, do me something nice, yeah. Carry your matter, girl, I love your body, baby girl, I love your body, now your body, now your And your body, girl, I love your body, your body, your body. Hey, look at my baby, the woman so nice and her skin so clean. She call it my love like a sweet 16. But for that, I know what she can do, my thing. She's so in love with me, it's a blessing that I found a queen. And she doesn't care if I'm poor or rich. I give her my love to eternity. Oh no no no, God I promise I will be there for you. Oh no no no, if you ever leave I go hunting for you. My queen, kiss you first thing in the morning, oh. For me, baby never treat you funny, oh.